Hi there. In this video, I'm going to show you how to calculate the least common multiple of numbers and of polynomials. And sometimes we'll look at adding and subtracting fractions. And in those cases, we're going to have that common denominator, also known as the least common denominator. So I'm going to look at them all in terms of just the numbers, but you can think of that as the 6 and an 8 in the denominator of a fraction, and then we're looking for the least common denominator. So some of you are going to look at this and go, I know the answer to this is 24. Which is wonderful. I'm grateful that you can do that. But others are going to look at this and go, but how do we actually get to 24? You know, I look at the next example, which says 12, 14, and 15, and can you just automatically see the least common multiple? Maybe, maybe not. So if we can't, what I like to do is show you how we actually get there. So I'm going to take my two numbers, and I'm going to prime factorize them. I'm going to take the 6. Well, prime factors of 6 are 2 and 3. The prime factors of 8 are 2, 2, and 2. Now, being it's the least common multiple, that means that my least common multiple has to have all the factors of 6 in it, and it has to have all the factors of 8. But we don't have to double things up. So what I like to do is I like to start with one of my numbers. I'm going to start with the 6 in this case and go, well, the 6 has factors of 2 and 3. Now, what is it missing that the 8 has? The 8 has 2 more 2's in it. Now, maybe you would have said, well, maybe I wanted to start with the 8. The 8 has factors of 2 times 2 times 2. And then you can look at it and go, well, what is the 8 missing that the 6 has? And it's missing the 3. Now, it doesn't matter which situation you're looking at. Either way, when I multiply all of these together, when I started with the 6, I still end up with 24. Or if I go this route where I started with the 8, my least common multiple is still 24. So in the end, the least common multiple, yes, is 24 because we found the factors of each and then figured out, well, which ones are missing from each number. And we found our least common multiple. So in this next one, when it's 12, 14, and 15, I look at my 12 and I go, what are the prime factors? Prime factors are 2 times 2 times 3. And then I work my way to the 14. Prime factors of 14 are 2 and 7. And last but not least, the 15 has prime factors of 3 and 5. Now, it doesn't matter which number I start with, so I'm just going to start with the 12. I know that all the factors of 12 have to be in my least common multiple. So I have the 2, and the 3. And now I ask myself, well, what's the 14 have that's missing in my least common multiple? Well, the 7 is missing. The 2 is already there. I don't have to put that one in there as well. And then I go to the 15 and go, what's that one have that's not in my least common multiple yet? And that's the 5. So now I just multiply all of these together. The way that I would do that, I would take the 2 times 2 times 3, which is 12. I'd multiply by 5. 12 times 5 puts me at 60. And then 60 times 7 puts me at 420. Now I'll throw some variables in it so that we create monomials in this case, and I want to find the least common multiple. Now it's going to be the same process. I'm going to take my first monomial in this case, the negative 9a cubed b, and I'm going to factor it. Well, that would be negative 9 times a times a times a, and then times b. Do the same thing with the 12a squared bc. Factors of 12, 2 times 2 times 3 times, and then a times b, and times c. So now I have to find that least common multiple. So I'm going to start with the red. Every factor of the red has to be in my least common multiple. So I know I'm going to have, you know what? I don't like what I did here. Why did I do negative 9? I should have been a negative 1, a 3, and a 3. I apologize for that. Let's go that route. So now in my least common multiple, I know I'm going to have the negative 1. I'm going to have the 3. I'm going to have the 3. I'm going to have those 3 A's and a B. And then I just have to ask myself, well, what is this least common multiple missing that the blue had? Well, I see that it's missing 2 2's. I already have a 3, so I don't need the 3 from the 12. There's these 2 A's, but I already have the 2 A's from the red. A B I already have, but I don't have a C, so that has to be in there. And now I multiply that all together. Well, -1 times 3 times 3 times 2 times 2 is going to put me at -36. And now I have 1, 2, 3 A's. So A to the third. I have a B. So you know what? I don't need that times sign. I'm just going to leave it as B and then C. And there would be the least common multiple of those two monomials. Now, if I get to 3 monomials, not really any different. I'll do the same thing. I'm going to prime factorize each one. So I'm going to have 2 times 2 times 2 times 2 times m. Here, I'm going to have -1 times 2 times 2 times 3. And then I'm just going to leave this as m squared and then n. And then last but not least, we have the 2 times 2 times 2 times n squared. And the reason I did that is I think sometimes when we get those exponents to be really large, it's kind of a pain to write out all of those letters. And I think we're going to be just fine if we leave it in exponent notation. Now, my least common multiple, I know has to have all the factors of any one of these. So it doesn't matter which one you start with. This time, let's start with the blue one. So I know my least common multiple has to have a 1 in it. It has to have a 2, another 2, a 3, m squared, and n. Now, what's missing that the green one has, the 8n squared? Well, I noticed that there's 2 2's already in my least common multiple, but the green has 3 of them, so I'm going to need one more n. And then I also noticed that I have n squared over here, but I only have n to the first here, so I know I'm missing another n. Then I go to the red. What is it missing? Well, now I notice that my least common multiple down here has 2 2's from the blue, a third from the green, but I need 4 of them, so I still need one more red. Yeah, we'll put it at the end. And then m, well, we already have m squared, so that's taken care of. Now I just multiply all of this together and figure out what do we get. Well, if I multiply all the 2's together, that puts me at 16. 16 times 3 is 48, and then times -1, so I'm at -48. And then we have m to the second and n to the second. And there is my least common multiple of those 3 monomials. So what happens when we get into polynomials? Same thing's going to happen. We have to factor. Well, in this first one, x minus 1 and x plus 4, those are already factored. So I don't have anything else. So my least common multiple of those two is going to has to have a factor from the red, and we're going to have a factor from the blue. Some could say that there's your least common multiple. Other times you're going to want to look at it and actually multiply that together. So if we were to FOIL it, we'd end up with x squared plus 4x minus x, and then minus 4, and put that all together for x squared plus 3x minus 4. There's your least common multiple. Sometimes we'll also display it just as the factors. Now on this next one, these I notice that I can actually factor them. So when I factor them, my first one, my x squared minus 1, we have the difference of 2 squares here. So my 2 factors will be x plus 1 and x minus 1. And in this one, I notice that this is a perfect square trinomial where my 2 factors are x plus 1 and x plus 1. And then we go on and we look for our least common multiple. Well, remember, our least common multiple has to have all the factors from the red one, so it's going to have x plus 1 and x minus 1 in it. And then it's also, I look here and go, well, what is that least common multiple missing that my blue polynomial has? Well, it's missing an x plus 1 factor, so I'm going to have to get that one in there, like so. So we could leave it written like that. We could also write it like this, where I notice that I have x plus 1 and I have 2 of them. So I could also write my least common multiple like this. We could also go through and actually multiply that all together, FOIL, and then do another kind of FOIL problem. But I'm just going to leave it like this, where there's our least common multiple. And then I have my last one here where I have my different polynomials, and I'm going to do the same thing. I'm going to factor. So the first one I notice, factors of, oops, I guess my variable's w this time, not x. So we have w minus 3, and we'll have w plus 3. This one, we're going to have 3 times 3 and then w squared. And then my last but not least, this one's going to be w minus 3 and w minus 3. And then let's put it all together to get our least common multiple. So I know we're going to have, oops, all the factors from the red in our least common multiple. And then I just go through the green. I go, well, what's missing from my least common multiple that my green has? Well, it's missing everything that's in the green. So I'm going to need the 3 times w squared. And then what's my least common multiple missing that the blue has? I look at it and go, it's missing another w minus 3. We already have one of them, but we need 2 of them. And there we go. So when I put it all together, I'd multiply my 3 times 3 to get w, or 9, excuse me, and then I'm going to have my w squared. Since I have 2 factors of w minus 3, I'm just going to write it as w minus 3 to the second, and then the w plus 3. And I'm going to leave this as my least common multiple. And that's going to conclude my lesson on determining least common multiples or least common denominators if they would be fractions.